here are the notes for Math 3. We have our Lesson 1, and this lesson is going to be on power rules review. Okay, so here are all the power rules that we have talked about in math up until this point, right? Whenever you have the same base, different powers, you add and you're multiplying them together. With our power rule, you're adding our powers, right? If we flip it and do division, we're just going to subtract them, right? Anything to the 0 power is just going to be 1. I could say, let's do 1,257,000,000, 1,257,230,170. I don't know, I'm making up a number. All to the 0 power, it's going to end up being 1. Okay, doesn't really matter the number. Anytime you have a negative power, you're just going to flip it. Okay, so see whether it's on top or on bottom, we're just moving it either up or down depending on which direction. Okay, and then anytime we raise a power to a power, we just distribute the powers. Okay, so if I have x to the m times n, and I'm raising it to the a power, it doesn't matter what the power is, I'm just going to multiply those together. Okay, and that also works for over division. Okay, so example 1. Okay, let's just jump right into it. Okay, so you are going to have, I like to rearrange it to make it a little easier the first couple times. So we have 16 and 14. So we have 16 times 14. Then we're going to have x to the 5th power times x squared. Then we have y to the 4th power, y squared, right? I'm not going to expand it, but you get the idea. If I do 16 times 14, let me go ahead and pull up a calculator really quick. We can go ahead and get rid of all this work really quick. We have 16 times 14. It's going to be 224. Then we have x to the 5th power times x to the 2nd power. We're just going to add 5 plus 2, and that's going to end up being x to the 7th power. And 4 plus 2 is going to end up being y to the 6th power. Right? That's the example 1. Okay. Should we review? Slide the calculator over. And now we're going to look at example 2. Right? So we want to, again, fully simplify using only positive exponents. We don't want any negative exponents in our final answer. Okay. Nice thing about this one is there is no coefficient on the bottom, so we can just go ahead and write that 27 on, just move it over. All right, so now I have a couple different ways you can think about this. You can use the rule, that is like the preferred way, but if you want to visualize it, you can also expand these out, and you'd see that 4 x's are going to cancel out. So I can write this as x to the 4 minus 8. We can say, remember that when we don't have a power, there's a 1. So we can say 1 to the 3 minus 1. So we have 27 over x to the negative 4, y squared. We just have to move this x down, right? So there's a 1 down here, so we're going to have 27. I'm going to show this. I'm going to move this down because we have a negative power. So we're going to end up with y, got to move the calculator out of the way. 27 y squared over x to the 4th power, and that is your final answer. That's all we can do for example 2. Okay, again, I'm just using our power rules. All right, so example 3, and we want to fully simplify, right? This is getting you practice raising powers to a power, right? So I can distribute, right? There's a 1 here, we have a 4 here, and we have a 2 here. So we're going to have 3, 1 times 5 is 5. 4 times 5 is going to be, you have x to the 20th and y to the 10th, right? So now we just need to figure out what 3 to the 5th power is. So we're going to say, let's go down one line, 3 to the 5th power is going to be 243. So our final answer for this problem ends up being 243 x to the 20th power, y to the 10th power, because we can't simplify the x's or y's, and the coefficient is the number by itself. Okay, it's example 3. So now example 4, again, we have some negative powers now, right? So really pay attention to where, if you have any parentheses at all, okay? So if you had parentheses, so it's like, for example, if we had negative 5x to the negative 3rd power, right? It's going to be very similar but different, because what's going to happen here is this negative 3 is only going to go to the x. But with this problem, it's going to be the whole entire problem, right? So if I wanted to write it, let's do this left-hand side in red. So I'm going to have negative 5 on top, and I'm going to move x to the 3 down. And we are actually done. That's the actual answer to the problem. hypothetically speaking, if I had to solve this problem, I would just move this over, right? So now, in blue, I'm going to move everything down. So I have 1 over negative 5 x to the third power, right? So now we have to distribute it inside, right? So we're going to have 1 over, this would be negative 5 to the third power. We have x to the third power. Well, negative 5 to the third power is just going to be negative 125 x to the third power. Okay, so see the difference, know the difference, pay attention to where your parentheses are, especially when you have negative exponents. Okay, or actually not just for our negative exponents, but any time we have a power. Okay, all right, last 2 examples for today. We have, was exemplified by 2 problems. We're just going to be working on more advanced problems, right, where we have all the rules combined. Okay, so if we look at here, I like to work my way from outside in, and so I'm going to take this 2 and I'm going to distribute it inside. Okay, so I have negative 3 to the first power. This is going to be negative 3 to the fourth power, because 4 times when we raise a power to a power, we multiply. And then I have negative 1 times positive 4. We're going to have c to the negative 4. And then on bottom, we're going to have negative 12, c to the 7th. Okay. All right. So now we have no parentheses. Now we're just working. I like to get rid of my negative exponents. Okay. So I'm going to move this exponents next. I'm not going to try and simplify it. I'm just going to copy it down. Right. So we have negative 3 to the fourth power. Then we have negative 12. We have c to the fourth, c to the 7th. Okay. If you want to, remember this is in parentheses. We're doing the whole entire thing. Be careful when you're doing that. Negative 3 to the fourth power. Let's go ahead and work with that right now. Negative 3 to the fourth power. You're going to get 81 on top. We have c to the fourth power and c to the 7th power. Same base, different powers. We're going to add them together. So we get c to the 11th. And on bottom, we have negative 12. Okay. So now we just have to simplify our leading coefficient for this problem. We have 81 over 12. Right? We're looking for numbers that will go into that are divisible by 81 and 12. Okay. So if we think about it, I know that 3 goes into both of them. So we're going to end up with, well, 81 divided by, let's do this. Let's do 81 divided by 3 is going to be 27 on top. And negative 12 divided by 3 is going to be negative 4. We have c to the 11th power. Right? And we can rewrite this so that the negative's out in front, but this is the final answer, right? You're done at this point. So again, get rid of your exponents on the outside. Move your negative powers so they're gone and you don't make mistakes with them. And then you're just simplifying at that point. Okay? Okay, so last one. Again, I like to work outside in. So we have a 1 here. So we're going to have 5 to the negative fourth power. We have s to the 4 times negative 4 is going to be negative 16. And then we'll have q to the positive 4, because negative 1 times negative 4 is positive 4. On bottom, we're going to have 5 s to the negative 3, q to the 4th. Okay. Okay, so I'm going to move the negative exponents. So we're going to get something that looks like this. I'm going to move 5 to the 4th power down. I'm going to move s to the 16th power down. I'm going to leave q to the 4th power on top. And then we're going to have just 5. And we're going to move s to the 3rd power. And we're going to have another q to the 4th power. Okay, so just to refresh, if we're looking at this, this got moved down. This got moved down. This got moved up. Everything else stayed the same, right? So our q to the 4th power, our 5, and our q to the 4th power all stayed the same. Okay, so at this point, I'm looking to simplify as much as I can. Same base. I can rewrite this as, oops, let's get rid of the calculator so I can see the pen. All right. A couple things right off the bat. I have q to the 4th on top and q to the 4th on bottom. These are actually going to go away, right? 5 divided by 5 is 1. Q divided by q is 1. So if I have 4 q's on top and 4 q's on bottom, it's going to go away. Another way to think about this, if you want to use our rules, if I went to subtract using our quotient rule, we'd have q to the 0 power, which ends up being 1. Again, same idea, goes away. Don't worry about it. Okay, so now we have 5 to the 4th power and 5 to the 1st power. This is just add them. So we can do 5 to the 5th power. We can use our calculator for this part. We can say 5 to the 5th power, and we'd get, oops, I'm skipping ahead, 3,125. Sorry, I'm going to slow down a little bit. All right, so there's that. Now we have 3 s's on top, 16 on bottom, right? So if we do s3 minus 16, we'd get s to the negative 13. So we end up with 13 s's on bottom. Okay, so it's going to be s to the 13th power, and there's nothing left on top. So we're just going to write s to the 13th power. Because there's nothing left on top, we need a placeholder. We need to make sure we include that 1. So your final answer should be 1 over 3,125 s to the 13th power. Okay, and that is the end for lesson 1. If you have any questions, please contact me and use my email or Parent Square.